Hi guys, this is Kim Llanos here, and I am going to do the first half of our team project presentation, and then my awesome partner Jocelyn is going to do her half of the presentation. So I'm going to be doing the 7 steps of the functional development process. Step 1, clearly define the problem. Step 2, create the test matrix. Step 3, outline the solution. Step 4, test the algorithm. Step 5, translate the algorithm into code. Step 6, run the test cases to verify that the code is working as specified. And step 7, the best part, deploy the changes to the repository. So step 1, clearly define the problem. What does the function need to do? Well, we needed to calculate the wagon weight that included the weight of the wagon itself, plus any food and non-food items, included hunted animals and gathered plants, the total sum of which could not go over the set maximum wagon load weight of 4,000 pounds. Our goal was to create a function to calculate those conditions. The function that we created was called calc wagon load weight. So step 2, create the test matrix. As we step through the test matrix, we found that we were missing logic that needed to be added. We also had extraneous logic that was unapplicable to the wagon load weight that we were calculating. So this is the next step in the development process. Create the actual test matrix and table of memory locations, plain computer, which encapsulated business logic for the hunting and gathering situations that our team may encounter along the trail. We needed business logic for the following situations: valid, where the max wagon load weight is not reached; invalid, where max wagon load weight is reached; the upper boundary, where the added weight is right up to the limit of the max wagon load weight; and lower boundary, where the wagon has a little bit of weight and the added weight is really nominal. So for the valid situation, our starting wagon weight was 3,000 pounds, and we added 45 pounds of hunted animals and 30 pounds of gathered plants, for a combined total of 3,075 pounds, which is well within the allowed max wagon load weight of 4,000 pounds. The first invalid situation was when the added animal and plant weight to the existing weight or current wagon weight went over the maximum allowed load weight of 4,000 pounds. We started with a wagon load weight of 3,990 pounds, and we added the same 45 pounds of hunted animals and 30 pounds of gathered plants, for a combined total of 4,065 pounds, which is 65 pounds over the allowed max wagon load weight of 4,000 pounds. The next invalid situation is when there are no available animals to hunt or plants to gather. Even though our starting wagon weight for this scenario was 3,000 pounds, there is no opportunity to add hunted animals or gathered plants to our wagon. The upper boundary wagon weight for our scenario, at least, was very close to the max load weight. We started with a weight of 3,955 pounds and 3,970 pounds, respectively, and added 45 pounds of hunted animals and gathered plants, respectively. Adding just 45 pounds of animals to the wagon brings the total wagon load weight to the allowed maximum of 4,000 pounds. Also, adding just 30 pounds of plants to the wagon brings the total wagon load weight to the allowed max of 4,000 pounds again. The lower boundary wagon weight scenario takes a nominal wagon weight and adds hunted animals and gathered plants. We started with the wagon weight of 1,300 pounds. We added the same 45 pounds of animals to the wagon, which brought the total wagon load weight far below the allowed maximum of 4,000 pounds. We also added the same 30 pounds of plants to the wagon, which again brought the total wagon load weight far below the allowed maximum of 4,000 pounds. After getting the business rules down, we figured out exactly what the function would need to do, and after the text matrix and table of memory locations was created, we then wrote the pseudocode /algorithm. our function, the calc wagon load weight function, which is called from the resource control class, used the parameters of team animal weight from the team class, team plant weight from the team class, current wagon load weight from the team class, and max carry weight from the wagon class. Our pseudocode comprised of the logic to check for invalid parameters, namely, if the wagon load weight goes over the maximum wagon load weight with the addition of hunted animals and gathered plants. If it does, then an error is returned. This is the algorithm with real values that we used in our testing. If there are no animals to hunt, an error is returned. If there are no plants to gather, an error is returned. With the text matrix and table of memory locations created and tested, and the pseudocode written, and the correlating logic validated, we were then ready to write the actual Java code, the fun stuff. Java code for the business logic, which is no available animals to hunt. As you can see, if there aren't any, it's going to return an error. This is the Java code for the business logic of no available plants to gather. Again, it's going to return an error. This is the Java code for the business logic of the maximum wagon load weight being exceeded, which returns an error. Or if the max load weight of the wagon is reached, an error is returned. This is the Java code for valid logic, which returns the current wagon load weight, which begins with the calculation of the team animal plant weight. And that is the sum of the team animal weight plus the team plant weight. And it is then added to the current wagon load weight. When the value for this calculation is less than the max of the wagon load weight, the current wagon load weight is returned. After creating the calc wagon load weight function in the resource control class, we then wrote the test case within the resource control test file. This is our valid parameter test case with the values we used in our memory of table locations and test matrix. This is our test case for added animal weight to the wagon exceeding the max load weight. This is our test case for added plant weight to the wagon exceeding the max load weight. This is the Java code to test the upper boundary weight limit. This is the Java code to test the lower boundary limit. This is the Java to test that there are available animals to hunt. And this is the Java code to test that there are available plants to gather. This is the Java code to test when the addition of both hunted animals and gathered plants to the current wagon load weight would exceed the maximum wagon load weight. Okay, I am now going to test our calc wagon load weight within the resource control test.java file. That's what we want to see, 100%. As you can see, all of our test cases have an expected result and the actual result. Everything's good. Now we just deploy to GitHub. To do that, we do the commit, we do a pull, and then a push. Okay guys, that's it for me in my part of the presentation. I'm now going to hand you off to my awesome partner, Jocelyn. Thank you.
Java selection statements include the if statement, if-else statement, if-else-if statement, and the switch statement. The if statement is used when there is only one true action. If the condition evaluates to true, the statements in the block are executed. If the condition evaluates to false, the block is skipped and it moves to the next statement. Here's an example from our code of an if statement, showing the condition and the statements executed if the condition is true. An example of this would be if the required reading said to look at Chapter 3 in the Java textbook. If you have the book, you will look at the chapter. Otherwise, you won't. The if-else statement is used when there is one condition and it has a true action and a false action. If the condition evaluates to true, the statements in the block are executed. If the condition evaluates to false, the statements in the else block are executed. Here is an example from our code of an if-else statement showing the condition and the statements executed if the condition is true or false. An example of this would be when I attempt to do my homework on the computer. If the desktop is available, I use it. If it's not, I use the laptop. The if-else-if statement is used when there are more than two actions and each has a different condition. Each condition is evaluated. If it evaluates to false, the block is skipped and the next condition is evaluated until it evaluates to true. When it evaluates to true, the block is executed and any remaining conditions and blocks are skipped. The last else is executed if none of the other conditions evaluates to true. Here's an example from our code of an if-else-if statement showing the conditions, the related statements executed if the condition is true, and the statements executed if no conditions are true. An example of this would be if one of my children asked me to get them a book. If the 11-year-old asks, I give him A Wrinkle in Time and he reads it himself. If the 9-year-old asks, I give her EJ-12 and she reads it herself. If the 6-year-old asks, I give her Pinkabella and help her read it. If the 3-year-old asks, I give him Inside Construction Sites and read it to him. If another child is visiting and asks for a book, I give them 3 different books to choose from. The switch statement is used when you want to compare the value of an expression to a set list of valid values. The evaluated expression is compared to each valid value, and when a match is found, the statements are executed. The default at the end of the switch is executed for any values not in the list and returns an error. Here's an example from our code of a switch statement showing the expression, the valid values, their related statements executed if the value matches, and the statements executed if no value matches. An example of this is a box of donuts with 12 different kinds in it. When someone asks for a specific donut, you look in the box for it, and if it is there, you give it to them. If there isn't one of the kind they asked for, they are told there aren't any and they don't get a donut. The scope of a variable is where the variable can be referenced and used. This is limited to the block where the variable is defined. When a variable is used, Java looks in the same block for a definition. If a definition is not found, Java moves out a level to find the definition. Because the scope of a variable is limited to the block where it is defined, you are able to use the same name for more than one variable in a class. Here is an example from our code of variable scope showing where the variable is defined, the block it is defined in, and where it can be used. The lifespan of a variable is when the variable is active in memory and can be used. It starts when the variable is defined and memory is allocated for it. It ends when the end of the block it is defined in is reached and the allocated memory is released. Here's an example from our code of variable lifespan showing where the variable is defined and where the block it is defined in ends. Primitives, which include integer, float, boolean, and character, are passed by value when used as parameters for a function. The actual value of the primitive is passed and copied to the variable. Here's an example from our code of a primitive being passed by value showing where the variable is defined, assigned, and passed to a function. An example of this is when your child asks to borrow money and you give them $10 to spend. They then have the actual money to use. Object instances are passed by reference when used as parameters for a function. The memory location for the object is passed and copied to the variable. Here is an example from our code of an object being passed by reference, showing where the variable is defined, assigned, and passed to a function. An example of this is when someone wants to come to your house and you tell them your address. You give them the location for your house and then they are able to go there when they need to. This concludes our presentation on the 7-step functional development process, test matrix design and functional testing, selection statements, variable scope and lifespan, and passing by value and reference.